general questions? No? Then you can see the schedule first. All right, here is the schedule. Today, I will cover the chapter 4 ship design procedure. And in the break time, oh, I did not send you makeup class hour. I will send to TA the file of previous year, how they find out the makeup class. And then also we will make a project team up leaded by TA while we have a break time. Okay, so let me find out the makeup class of previous year. Okay, here it is. Oh, this is a decision. A team making. So it's not what I want to find out. Okay, where is it? Just schedule. No. Oh, here is the lecture. Makeup class. Jihu, you already have this file, the older version.
Yes.
And second tab shows the makeup class. In this way, you can find out among 7 members or 6 members to find out similar available slots by exchange your information.
Okay.
So during the break time, please find out, or you can, it is not hurry. So you can do after the class hour. But anyway, this is the way we find out makeup class hour. And project team, as I told you before, that we will have 2 teams, 3 members per team. So that can be the way. The only requirement is heterogeneity. That is also led by TA during the break. All right. So let's start with the material on ship design procedure. So this is the book we are covering, and chapter 4 is the design procedure. And this is one of the famous curve which shows the nature of the design. At the horizontal line axis shows a design timeline. So time is going up from left to right. And then the first curve is going up from time along the timeline. That shows a design knowledge or cost used, the money used for the design and also construction. So as you say, let's say we are trying to design and produce FPSO or cruise ship. At the beginning of time development, there is no knowledge on this, or very low, small, little knowledge at the beginning, and also cost or money is spent is very small, but it increases especially during the production start in the middle or just after the middle, the stiff curve is going up. So much knowledge is coming, gathered, and also money is spent much during the early stage of construction. The second curve that is going down from the start to the low end is freedom to make changes. At the beginning, there are so many new ideas, new requirement, and also new, how can I say, ambition, right? It is, you can experience very similar things in your term project, right? Very similar. So that term project is a kind of a designing and production, depending on your subject. But anyway, at the beginning, you can change even the subject, even the title, even the team schedule, any things. So there are so many freedom to make changes. But toward the end of the schedule or timeline, you cannot change. It is very difficult to change, or it is very expensive to change. If you are think about building your home, at the beginning you can try a Korean style home, or can try a Western style home, you can try a concrete house, or you can try a wood house or steel house. There are so many options. But as time goes on, towards the end of construction or near the end of construction, it is not easy to change any small things. I know if you want to change something, it takes time and it takes money much. That is the nature of design and construction of any item. In the middle, there is an arrow and showing that front loading. That means the designers want to move the curve in this way. So curve can be moved like a curve like this one. So early stage, the steep increase of knowledge is going in early stage of the design. We call this is a front loading. That is the wish of designers, but that can be done by different methods, something like a computer application or other softwares and methodologies. We'll see more in the later stage. And this one shows, we call this is a spiral. That is very special to shipbuilding area. I did not see such a spiral in other domain or industry or construction or designing. Probably, I guess, the nuclear power plant have a similar, but I guess more similar things are happening in airplane or space shuttle or spacecraft. But anyway, in ship design, we start from this point, the naval architecture, and goes to structural design, and then propulsion machinery design, and auxiliary system design, electrical system design, outfitting system design, and go on the second round, all same things: naval architecture, structure, propulsion, auxiliary, electrical, outfitting, and another third round of naval architecture, structure, propulsion, electrical, fitting, and then finalize to the solution, the output of the design. That's the way. Here you see that many different disciplines are used, and also iteration among them. That is the unique characteristic of ship design process. And this is almost same one, but a little bit more detailed description here. And it goes in counterclockwise but this is not meaning the direction is not very important one. Just the drawing person choose the direction. And let's start from mission requirement, proportion, preliminary powering, lines, body plan, hydrostatic, float of length, arrangement, structure, powering, light weight, capacity trim, damage stability, and cost estimation. And second round, and then third round, fourth round, it is how many? 6 times of iteration. Oh, many. And then the color says it is a concept design phase, and second one is a preliminary design phase, and then third one is contract design phase, and last one is a detailed design phase. And then these two items they are saying together as a whole form design. So these topics we will cover in this class of textbook 1, or it can be used to any kind of design of transportation systems. Can be an airplane, can be a car, or even we can use this kind of items, similar items to power plant, nuclear power plant, or construction. Okay, question? And this one is also similar one, but I think the character font size is too small, so I could not read it clearly, but this one is not for shipbuilding. This one looks different anyway. So they are using similar style of design, iteration of many different items. So the nature of designing or creating a design, new design, there are two basic phases. One is creative one, the other one is analytical one. In other words, it is generate and then test. Or you can say that designing and analysis. Or another way, it is something like a synthesis. Let me write down in this way, synthesis. Oh, I cannot remember the synthesis. Correct wording, spelling. I cannot remember this. No, that is not correct one. Let me find out the correct synthesis. Is Y, S-Y, synthesis. Right, this one is correct. Oh, design. Yeah, design is almost the same as a synthesis, but another way. So synthesis is more comparable to the analysis. So gathering, collecting, or integration. Integration is something like a synthesis. And generate and test, that is, how can I explain this one? When we make a sentence of English, we start to use a number of words. Let me say there are 5 words to make one sentence. Then generate stage saying just combination, random combination of or sequencing of words, 5 words that can create, say, how many combination we can provide, factorial something, how many 100 of them, and then test cycles, see what can be the grammatically correct sentence, and then what can be the correct, has the correct meaning of that sentence. So generate is just putting them together, something like a Lego block. You put any pieces of Lego in random ways. Only the requirement is correct connection between them. And then test cycle says it looks like a final shape, something like a tank or airplane or robot. So that many of them is disappears, discarded. Only selection is go to which one is generated, looks similar, looks promising towards the target. So that is the way. And design is also similar. That we just create many ideas, concept cars. So usually when we design a new car for next year inside the company, such as Hyundai Motors, many people try to make new designs, concept cars, say 10 of them for the next year. Then there is an evaluation cycle. Many people attend, including the president of the company, and then they select some of them. There's something like audition or competition together. So that is done by cycling many times, iteration of two basic phases. So design there is no single correct solution. There is a special characteristic of the design. There is only a best or good, acceptable, or we can say optimal design, not correct. There is optimal, that balancing various design requirements. But in comparable to design analysis, there is a single correct solution, even though we don't know the correct solution yet. The weight of the car, or weight of the house, or weight of the ship, or weight of the airplane, if there is a product is there, there should be one single correct solution there. But we don't know how to measure that weight. And cost is two, and speed of car, speed of airplane, collapse pressure, or collapse strength or weight or pressure, that can be, there is one single correct number there. But we don't know. We may or may not know the correct solution. So, but the nature has difference. Design, there is no single correct solution there. But analysis, there is one single. We know that there is one single solution, correct solution. But we don't know whether we can find out. We are trying to find out. Question? No. And then design deliverables. What can be the output of ship design process? The main dimension, the size and capacity, how many cargoes can be carried. Let's say a passenger car or small truck I'm designing. Then what can be the size of the car or truck? And how many cargoes can be carried by a small truck I designed? So that can be the capacity. So designer should know, and then the customer who requests the car design, they should know the dimension and capacity. And general arrangement and preliminary lines and midship section, it is 3 key drawings. I already told you before. And then there are more. There is a preliminary hydrostatic calculation, including buoyancy. So how many tons can be carried by the ship is calculated in this way. And also preliminary weight calculation. That is the weight of the ship itself. So there should be a balance between two, buoyancy and weight. That is a static stability or weight calculation. So buoyancy is something like total weight of water that is displaced by the ship itself. When ship is floating, the ship displaces, push down the water, seawater. So amount of water that is displaced by the ship, that is a total weight of buoyancy. Responsive pressure or force coming from the seawater to the ship, right? And weight is the weight of the ship itself, made of steel, made of a cargo made of personnel inside and also several fuel oil and all together. That is the weight. So weight of the ship itself should be balanced by total buoyancy force. That is the main weight calculation. Then can be further down into cargo condition, deadweight estimation, electrical load balancing, production hours. That is how many days can be required to construct one ship. That is important for shipbuilding company and also the owner, the request, the customer who ordered, requested to build a ship. It can take, let's say, 30 months. But some customer want to finish this one into, say, 25 months, even though they can provide more money than contracted. So estimation of production hour is also important. If I want to build my home near the Daejeon city, then I need the money, I need the land, but also I need to know how many months can be used for the construction of the house. So the master plan for the production process, the scheduling of production, and finally the cost estimation. For my home, new build home, how much money is required? Then I need to borrow money from the bank to build my home. That is similar to a shipbuilding company and a shipping company. Question? No.